In this chapter, we will be doing the calculations of arithmetic mean through different methods like the direct method, the assumed method, and the steep deviation method. The direct method to calculate the arithmetic mean. This is done for the individual series first. Here the formula to calculate the arithmetic mean for the individual series is x bar is equal to summation of x by n. Now we will use an example. Here x bar means the arithmetic mean which we will require to calculate. Summation x is the addition of all the data or the values, and capital N are the number of observations or the number of data. So now in the first example, we take the data. Here the data given are 5, 8, 10, 7 and 10. To calculate the arithmetic mean x bar, we first add up all the data, 5 plus 8 plus 10 plus 7 plus 10, and then we divide it by the total number of data, which is 5. So x bar is equal to 40 by 5. Here x bar is equal to 8 and mean is therefore is equal to 8. Now in this slide we'll be calculating the arithmetic mean for the discrete series. Here we take an example. Here the data given as x are 10, 20 and 30. The frequencies are 2, 3, 5 and fx, which represents the multiplications of frequency with the number of data. This is 10 into 2 equal to 20, 20 into 3 equal to 60, 30 into 5 is equal to 150. Now we will use the formula to calculate the arithmetic mean for a discrete series, which is x bar is equal to summation of fx by summation of f, where f represents the frequency and x represents the value or the data. So here we add up all the fx values. So we get summation fx is equal to 20 plus 60 plus 150, where the total we get 230, and summation f or the total frequency is equal to 2 plus 3 plus 5, which is 10. So we can calculate the arithmetic mean from the formula given above, which is x bar is equal to summation of fx by summation of f, which is 230 by 10. So we get x bar or mean equal to 23. So mean here is 23. Here we calculate the arithmetic mean for the continuous series through the direct method. Here in this method of calculation of arithmetic mean, we use the formula x bar is equal to summation of fm by summation of f, where x bar is the arithmetic mean for the continuous series and m represents the midpoint of the class, where midpoint m is calculated by adding up the upper limit and the lower limit and then dividing the total by 2. Here the midpoint is then multiplied by the frequency f, and then we use the formula to calculate the arithmetic mean, which is x bar is equal to summation of fm by summation of f. In this slide, we will be discussing about the assumed method to calculate the arithmetic mean in case of larger values. This is done for the discrete series. The formula to calculate the arithmetic mean is x bar is equal to a plus of summation of fd by summation of f, where d represents the deviation F represents the frequency. Summation F is the total frequency. The steps to calculate the arithmetic mean by the assumed method is: first we have to choose the middle value as the assumed mean from the given values. Secondly, we will have to find the deviation D, which is x minus a, and three step is multiply the frequency with the deviation, and the last step is applying the formula x bar is equal to a plus of summation of fd by summation of f. Now we will try to understand the calculation of arithmetic mean by the assumed method for larger values through an example. Here we take the value x as 10, 20 and 30. The frequencies are 2, 3 and 5, and the deviation is calculated by x minus a. So the first deviation will be 10 minus of 20, which is minus 10. The second deviation will be 0, 20 minus of 20, so it is 0. And the third deviation will be 30 minus 20, that is 10. Now we will find fd, which is frequency multiplied by the deviation, which is 2 into minus 10, which is minus 20, 3 into 0, which is 0, and 5 into 10, which is 50. Now, as we take the assumed mean as 20, so now we will calculate the summation of fd. So summation of fd is minus 20 plus 0 plus 50, which is 30. Summation of f, which is 2 plus 3 plus 5, which is 10. Now we apply the formula to calculate the arithmetic mean for the assumed method, which is x bar is equal to a plus of summation of fd by summation of f. So x bar is equal to a, which is 20, plus 30 by 10. So x bar is equal to 23. Hence mean is 23. In this slide, we'll be calculating the arithmetic mean for the assume method for larger values for the continuous series. Here the formula is x bar is equal to a plus of summation of fd by summation of f. But in the continuous series, here we require the midpoint. So in order to calculate deviation or d, we will require midpoint minus the assumed mean, which is d is equal to m minus of a. Now the steps to calculate the arithmetic mean in the assumed method for continuous series. Here the first step we will require is to find the midpoint m. The second step is that we will have to choose the assumed mean. The third step is to find the deviation m minus of a, and the fourth step is to multiply the frequency with the deviation. Lastly, we require to apply the formula x bar is equal to a plus of summation of fd by summation of f. Now we will be calculating the arithmetic mean through the step deviation method. Here the formula is x bar is equal to a plus of summation of f mu by summation of f into h, where a is the assumed mean, f is the frequency, mu is equal to m minus of a divided by h, where m is the midpoint and h is the class width. Total frequency is represented by summation of f. Now we will be calculating the arithmetic mean through the step deviation method for the continuous series through an example. Here we take the class interval Ci as 0 to 10, 10 to 20, 20 to 30. The frequencies are 5, 8, 7. Midpoint are calculated from the class interval, which is 0 to 10, that means 5, 10 to 20, that means 15, 20 to 30, that means 25. Now we calculate mu, which is equal to m minus of a by h. Here we get midpoint m from the table, and a assumed mean is equal to 15, and h is the class width, which is equal to 10, because here from the class interval we see that 0 to 10, 10 to 20, 20 to 30, the class width are 10. So h is equal to 10. So now we get mu is equal to minus 1, 0, 1. F mu is obtained by multiplying the frequency with mu. So 5 minus of 1 is minus 5. 8 into 0 is 0. 7 into 1 is 7. Now we calculate the arithmetic mean x bar is equal to a plus of summation of f mu by summation of f into h, where f mu summation is the total frequency, which is equal to 7 plus of 0 minus of 5 is equal to 2. X bar is then calculated from the formula a plus summation f mu by summation f into h, which is equal to 15 plus of 2 by 20 into 10, which is equal to 16. So mean is equal to 16.